Hello, I'm Reon Brand, and I want to talk to you today about a future study that I've done called Co-Emerging Futures. And in this study, I created a model for reflecting on different streams of future change that is shaping the world that we live in. In exploring this, I was reflecting on the progress that we have made, through going through all these different paradigms of socio-economic development, starting from the agricultural to the industrial experience, the knowledge economy, and the transformation paradigm. And I've realized, that we're seeing more and more this level of material progress had an incredible impact on the world. Now, all of this progress and material progress has been made possible by a 10,000-year period of really benign climatic conditions called the Holocene. And 10,000 years ago was when the agricultural age started, when we actually moved from hunter-gatherers to settling in towns. And that was the start of the path towards development and progress of civilizations. But now we see that this period of benign climatic conditions is coming to an end. And in the pursuit of progress, we have started something called the Anthropocene, which supersedes the Holocene, this period of benign climatic conditions. And the Anthropocene is a period where we see rising climate temperatures and the rapid decline of environmental conditions. So it's almost like what we are seeing now, it's a perfect storm, because we have rising temperatures due to CO2 release, due to our industrial activities and burning fossil fuels. We have with that, in a stunning environmental decline and collapse of ecosystems that we're starting to see. And there's also, at the same time, a very worrying decline in global governance. We saw America pulling out of the Paris Climate Accord. So there's a lack of global action to really address these issues. And so much so that we are now reaching the point where these issues are amplifying and can have consequences for global civilizations and even existential consequences for all species. We are heading towards a 2 degree centigrade temperature increase in the climate by 2055. What does this mean? 2 degrees doesn't sound so much. Many people will say, okay, this is just a slightly hotter summer. But it actually has an incredible impact on the environment around us. We are seeing now, and in the last 100 years, we've only had a 1 degree raise in temperature. Most of that happened in the last 30 years, because it's exponentially increasing now. And we see much stronger hurricanes. We see bleaching of coral reefs in the ocean. For example, the Great Barrier Reef is only 1% of the fish, of the mass of fish in the ocean, but it is 25% of the species in the ocean. We see incredible plastic pollution, that plastic is now penetrating all ecosystems, and even all food chains are affected by that. We see more and more mass migrations because of changing weather patterns and coastal regions being threatened. And floodings that happened every 100 or 200 years now starts to happen on an annual basis. And we see the rise of pandemics like the COVID-19 pandemic, which is a direct consequence of our impact on ecosystems. This temperature increase in the climate that we are seeing, it is very important that we try to limit that to a maximum of 1.5 degrees. Why is that? Because beyond 1.5 degrees, scientists agree that the process may actually become a runaway climate change, and it will start to accelerate itself. That is due to the fact that as the oceans warm, you get the release of methane, which is a much worse greenhouse gas than CO2 from the oceans, and it will actually perpetuate and accelerate this process. That means we have to have very strict targets to limit the amount of carbon dioxide we release into the atmosphere. Now, there's been several accords trying to limit this and to try to guide human activities to make sure that we stay within this 1.5 degrees centigrade rise in temperature in the next 100 years. However, we are not on track reaching those targets. In 2018, we saw a record release of 37.1 billion tons of CO2 into the atmosphere, and the same amount was released in 2019. So we are absolutely not on track. In actual fact, to get to the 1.5 or to stay within the 1.5 limit, we need to reduce by 2030 our CO2 release by 45%, and we have to bring it to zero by 2050. And by all the signs that we are seeing, this is not going to be possible. We have to realize that we are already in the middle of the 6th major extinction event that the planet is facing. Our planet is 4.5 billion years old, and complex life emerged about 550 million years ago. And in that period, there's been 5 major extinctions. And in some of them, for example, like the Permian extinction, 96% of all the life on the planet has perished. And that came about also due to massive amount of CO2 released, either due to a volcanic eruption or an asteroid impact, leading to global warming, changing ocean currents, ocean acidification, and you had the collapse of ecosystems. The 6th extinction that we are into right now, we can see species are already disappearing at more than 1,000 times the background rate. And this is the first extinction event that is not caused by a geological or an astrological impact event, but is caused solely by the activities of one species, and that being us human beings. So in 70 years, we've actually catalyzed the beginning of an extinction event, and we already have entered this extinction event. So coming back to my future study, it became clear to me that we cannot continue to look only from a socioeconomic perspective, because socioeconomic perspective is basically prioritizing human socioeconomic aspects, and we have reached a point where we have to think about the existential consequences that we are facing with the planet. So in the past, the way that we made sense of the future, you had in the era of modernism, you had people with big utopian visions. Then we started to develop more sophisticated societal and socioeconomic models like preferable futures, spiral dynamics, causal layer analysis, and all these methods of studying social change and socioeconomic change. But for this study, I realized we have to go beyond that. And this is why I wanted to include, as part of this study, also looking purely from an ecological point of view. And this is what I call a post-anthropocentric view, not only prioritizing the needs and the desires of human beings and of humanity, but looking from a planetary perspective. The human civilization and human progress cannot happen if the planet is compromised and all the ecosystems around us starts to collapse. Let us now take a look at how our socioeconomic paradigms model has evolved towards the co-emerging futures. The first thing that we see is the transformation paradigm is splitting and fragmenting into 2 directions. Why is that? The fact is that we have not one future, but we have several different streams of futures emerging. And one of the key reasons is that we have shifted from modernism, which was defined by visionaries who had like big utopian visions, towards the postmodern mindset. And the postmodern mindset is basically saying that there is not just one truth, but there are many truths, and it depends on your cultural background, your cultural experience, and your own point of view. And you have this sort of like fragmentation of truth that is actually have found a platform in the knowledge age, because what we find in the knowledge age is that there are interest groups who actually are trapped in these sort of like different views of the world. And that is brought about, for example, by search engines like Google. If I search something on Google and you search something on Google, we get different results. Why is that? Because these search engine algorithms gives us more of what we already like and what it thinks we already want. So it means that, people are getting trapped in this sort of like self-confirmation bubbles of like really different truths that are fragmenting. Now, let's look at the first split that we see here. The one I still call transformation, and that is what I call a preventative mindset. It's people who believe that we have to adapt our behavior, our consumption patterns, and the way that we interact with our environment to safeguard the planet. And that is a transformation direction. The direction going to the top, you will see, is what I call the transmutation direction. And that is an augmentative mindset. In that mindset, we fundamentally believe that technology can save us and can safeguard us. Even if the planet is compromised, we can find ways with technology to either restore the planet, or we can use technology to safeguard us irrespective of damage to the planet. And so these two different mindsets are driving us forward. And what we see is each of these two directions again split into two. So we have 4 different streams of the future. And these 4 streams of the future, each of them already have a level of momentum and a level of investment behind them. So I will start from the top. The transmutation. Firstly, the arm going to the top that you will see is a post-human or a post-biological future, and that is based on the belief that it's very much sort of like a belief that we are driven forward as human beings by enhancing our intelligence. And our biological form has become too slow and too non-adaptive to adapt to the same speed as, for example, artificial intelligence is developing. And it has its roots in the singularity theory of Ray Kurzweil, where artificial intelligence will exponentially start to accelerate. And the only way that actually we can keep up is that we have abandoned the biological form. It sounds very scientific, but I will get back to that later. I've given this the name Etheria because it means as human beings we abandon the biological form and we become part of the ether of something, a different form that is based on pure intelligence that is constantly evolving. The second arm is what I call superhuman towards transhuman. And that is something that you probably recognize very much today. Increasingly, we have very powerful technologies that will give us almost like superhuman powers to stay healthy for much longer, to live practically forever. So this is technologies that will make us more intelligent and will help us to live for a very long time. And that is the Immortalia direction. If we go again to the transformation arm, we will see it splits into 2. The one is the very well-known direction of sustainability towards a steady state where we believe, and I think all of us is familiar with that, and probably the majority of us will support sustainability because it is a direction whereby we adapt our management of planetary resources, and we are trying to create safe spaces for the planet to remain intact and to remain functioning while we can still secure a certain standard and a certain quality of life. And the last arm that I want to talk about is a fundamentally different direction, and it takes the direction that as humans we cannot continue to put ourselves and our own needs first. It's the direction of regeneration towards eco-entanglement, and I call this metaphor Gaia. Which is based on the theory of the Gaia, the book by Lynn Margulis and James Lovelock, who published this book in the 1970s to show the integrate interactions between life and the planet and how everything is really entangled as a single system. And we have to abandon the position of putting humans on top of nature and pursuing a planet only putting human needs first. It may make sense for us to dive a little bit deeper into these emerging mindsets because it has the fundamental underpinning for the model that we are discussing. So I created this model called the Flower of Memes and Meaning, and it just takes the key streams of religious and philosophical thought over the last 2 millennia or so together to show you that actually much of what we are thinking is kind of like, and that something that feels intuitive actually may have originated already 1,000 or even 2,000 years ago. And quite often our mindsets are shaped by very old memes, and we're sometimes not even aware of that. Now, if we look at, you know, all the incredible technological progress that we have made over the last, especially over the last century, where does this come from? Actually, we can trace this approach to progress, we can trace it back to the early Greek philosophers like Plato and Aristotle. They placed a very high value on logic and reason and on the mind. They believed in pursuing the search for the absolute truth. And, you know, there was this belief that there can be only one truth, and that's the absolute truth. And you can actually arrive at that truth through pure logic and reason, and even your senses are not to be trusted. Now, it is interesting, the Greek philosophers influenced not only Western civilization and Western societies, but it also had a big impact on more like Western religion, on Christianity as well as Islamic beliefs. For example, you know, the whole notion of good and evil came originally also from the thinking of the Greek philosophers. It was taken up by Christianity. The belief that humans are shaped in the image of God. So if we had, if the mind is and the soul is what distinguishes us from lower animals, by definition, we are worth more. And in Genesis, you also see this, Genesis, I think 1 verse 28, where God gave us dominion and to rule over the earth and to rule over the planet. Even if you are not a Christian, even if you are not religious, that idea has basically shaped human thought. Today, many of you may own a piece of land or own a property. We think that we are basically owning a piece of the planet because we fundamentally believe that, you know, we are on top of nature and we're actually ruling over nature. Also, what is interesting is that this sort of like interaction with nature, also early Christianity really saw nature and natural instincts of humans as sinful. So, you know, it's like lustful, or nature was something that is dirty. And that actually put the path, after the medieval ages, or the path of enlightenment, on a path towards like using science to conquer nature and subdue nature to our will. And some of the philosophers of that time, and the scientists like Francis Bacon, was really on a drive to say, okay, we need to start to understand how nature works, break it down into building blocks and configure it so it suits, I think, human desires and human needs. And you can almost view our entire path of progress as a kind of a war against nature. It's a war to try to subdue nature through technology. And I think what is also very important is that, you know, the Greek philosophers also already had the idea of objectivity, whereby you have to actually distance yourself and make objective sense of what is happening, and that is like the basis of truth and reason. Now, this kind of like Western reductionism reached almost like a pinnacle with like Newtonian laws of physics that helped us to predict how materials sort of like react and interact. And it helped us to actually develop the basis for many of the transformational technologies that we are seeing around us today. If we look at the early Oriental thinking, we see a very different path. Before I go there, the Western reductionism also increasingly started to, because we had this idea of building blocks or atoms, or that we can actually reconfigure, we started to develop almost like a machine metaphor of how the universe and how everything around us works. Even today, the way that we approach healthcare, for example, we see the body as a complicated machine where we can intervene and actually fix different parts of the body when we become ill. And this is today, if you look at how Western medicine is organized, you have a kidney specialist, you have a knee specialist, a foot specialist, and a brain surgeon. And we treat the body as if it is parts of a machine. And it's very different from the more Oriental philosophies that basically if you look at the Tao belief, there's this phrase called Wu Wei, and that is staying in the flow of nature. And the whole Tao philosophy is understanding, you know, how we interact with nature, and whatever we do, we have to stay into the flow of nature, which is very different from the Western approach of trying to subdue and trying to change nature and bend it to our will. Also, the sort of like fixed machine metaphor that we used in Western thinking, you don't find back in the Oriental thinking, because, you know, you have the model of yin and yang that you've all heard of, and this is sort of like this model of like two sort of like interacting opposites, which is a complex dynamic evolution, and it's not something that is sort of like fixed. But what is very interesting is, like, if we look at the evolution of this model, we find that quantum theory and the theory of relativity, the quantum theory of Niels Bohr and the theory of relativity of Einstein, was almost like a decisive moment that started to really raise serious questions about the way that actually we see the world and what we think is the underlying single truth that we thought we had. For example, you know, most of the Newtonian physics, we thought this was a singular truth and it could describe the entire universe, you know, understanding how the physics of material works. But if you look at quantum theory, that, you know, if you break down molecules to atomic particles, you start to understand that all these particles have a wave and a particle properties. And actually, there's this phenomenon called entanglement, where particles can be entangled over very, very long distances. And even particles can exist in two places at the same time. So all these Newtonian laws of how we describe nature is a contextual truth that basically fits us in the way that we develop our technologies, but is not the absolute truth, because the universe has an underlying structure that we don't fully comprehend. The same with the theory of relativity of Einstein, where gravity fields is shaping space-time. Now, what is interesting is that we find some of those models that they've created back in the very early Oriental thinking. For example, there's the concept of qi, which is how energy fields, and you know, like if you go for acupuncture, you know, the way that they manage to actually guide energy fields in your body, that philosophy of qi is how energy fields is connected throughout your body, but also throughout the universe, which is very similar to quantum theory that shows that the universe is actually multidimensional and up to 11 dimensions, and it consists of connected energy fields that is connected throughout the universe. So there's incredible sort of like parallels between very early intuitive thinking of the Oriental sages and the theorists that basically completely transformed our thinking of like the underlying nature of the world. The same with the theory of relativity, that the world is shaped by gravity fields that can warp space-time. There's this Confucian concept of Li, which is already sort of like, I think, more than 1,000 years old, that is the force field that basically gives shape to everything in nature. So it is interesting, if you look at this model, we have started with a belief, especially in the West, of reductionism, materialism, and that we can actually set deterministic goals and pursue that with technology to subdue nature. But since the 1960s, there's actually been this, and I mentioned before, this postmodern mindset, whereby people start to question that there's only one truth. Maybe there's more than one truth, and it's also that truth can actually be based on your own experience, your own intuition. And many thinkers start to leverage some of the ideas of early Oriental thinking. And what we are seeing now is that there's a shift towards what we call relationalism. And that means, and that is inspired by quantum theory, that everything is connected, and complex systems cannot be described only by the building blocks or the properties as you can do with deterministic Newtonian science, but the relationship between these particles gives it sort of like new properties that you do not find back in the individual building blocks. Okay, so let's get back to our co-emerging futures model, and we're going to dive now into these 4 different directions. The first direction that I'm going to dive into is Immortalia. It's the second stream from the top. And that is the quest to transcend Homo sapiens, or human beings, through technological progress. Now, this is a very kind of like anthropocentric view and an approach, and it basically values human progress above all. So it's really on this technological path of progress that we are seeing in the world around us. It's also, I think, especially if you look in America, you can really immediately recognize that. And it's like shaping the earth for human civilization on top of nature. And it's a very utilitarian mindset, whereby we want to actually constantly raise our standard of living through progress. And it is also very kind of like opportunistic, because it's driven by very individualist ideals. And it's about also controlling human and optimizing the human habitat for human civilization to flourish. However, and this is like the direction of Immortalia, we see now very, very powerful technologies that will be able to enhance our bodily and our mental functions, but it also will enable us potentially to live much longer. The only question we have to ask ourselves, if these technologies, will they be accessible to everybody? And the simple answer is most probably not. We already see, you know, and I've worked in different countries in Africa where you see the incredible gap between what we have in many places in the West and what many people living in rural areas have to get by with. And there's an incredible gap, and we see rising inequalities in the world. And these kind of technologies are able to create almost like a human super race that will leave most of humanity behind. Today, you find that I think the 26 richest people in the world controls almost 50% of the resources. So there's like these rising inequalities that, you know, is a very sort of like a dark side of this pursuit of progress. And it's made possible by what we call the 4th Industrial Revolution, that you have no doubt heard about. And it's about the convergence of many streams of the most powerful technological directions that we see today, including nanotechnology, biotech, hyperconnected Internet of Everything, AI and robotics, advanced manufacturing and automation of everything. All of these streams will start to sort of like come together and even merge with the human body to actually make us very powerful for those who can afford it. I mean, some of these like more advanced medicines today, there's been some medicines I think launched based on genetic engineering. I think in Germany, released on the market, I think it's 2 million euros for a treatment. You know, there's no ways that, you know, a person in a rural area in Africa can ever have access to those kind of benefits and technologies. But this is what this direction is about. So it's about augmenting humans with digital and physical technology. That is the one thing. We already have mind control neuroprosthetics. So that means that if you've in an accident lost your arms, they can make a prosthetic arm that you can fully control. It can directly be wired to your brain, and you can fully control that arm, your fingers and everything with your brain. There's also demonstrated that is already we are already able to create thought-controlled computers and machines, where you basically just use your brain to control machines around you. Elon Musk, you know, as the company Neuralink, and they are working on sort of like hybrid brain AI combinations, whereby they are developing a technology where they can do implants of nanoprobes into the brain that can allow them wirelessly to directly link your brain to artificial intelligence. So you will, artificial intelligence will become almost like an extension of your brain, and that is what they are aiming for. And there's also been demonstrations of technology that sort of like link your brain waves to other people. And, you know, they've shown that, you know, by doing this, they can actually, if people have to collaborate to perform certain tasks, or for example, to play a game, that they have incredible advantages over people who actually just collaborate as normal individuals or individuals in a team. So there's all these sort of like powerful technologies that will enhance our capabilities. Beyond that, there's also the frontier of molecular biology that will allow us to really reshape what it means to be human, because we have now powerful techniques like the CRISPR-Cas system. And what that does, it allows us to pinpoint specific points in our genes that we want to edit, and we can edit those genes, and it basically means that, you know, our genetic makeup is altered to give us certain advantages, to maybe to make us healthier or to cure a certain disease or to give us other advantages. Now, for now, most of that advances has been done on a somatic level. For example, it means if you have a rare kidney disease, you can basically, or a blood disease, or an immune disease, you can actually go and you can take some of your human cells, you can edit those genes, and you can actually overcome those functions or give enhanced functions. The danger is when we start to apply that technology to our germline, which means if we start to modify human egg cells or sperm cells to create, for example, better intelligence, faster reaction times, better memory, we can start to, in time, to make those modifications, and we will change the human race forever. And the danger of that is that we are only focusing in a very deterministic way on a specific goal, and we can think, okay, if we change this gene, we will have this sort of like function. But we have a very poor understanding of how these genes interact in the larger system. And over time, we may find that there are unforeseen consequences that we never anticipated. And then it's too late, because then we may have already generated a generation with altered genes. So this is the potential dangers. And we have powerful techniques like stem cells and organ bioprinting. A stem cell is an undifferentiated cell. And we have now techniques to take any cell, turn it into an undifferentiated cell. And then we can stimulate it to become any kind of cell. So, for example, if you have a disease and your kidney is destroyed, we can actually, in the near future, we can start to actually take stem cells, turn them into kidney cells, and use a bioprinter to print a new kidney and put it back. So this is the kind of like technologies that are able to actually keep us towards almost immortality and can make us potentially live much longer for those who can afford it. Let's go to the next future. The next future is the one at the top called Etheria, and that is the future towards like boundless intelligence and post-biological immortality. So this is the post-biological future that I mentioned earlier, and the driving force behind this is the fact that we see that AI and intelligence is advancing exponentially. And Ray Kurzweil has formulated this singularity hypothesis that there is a moment in time, which is probably not very far away, where artificial intelligence will advance at such a rate that it does not need human intervention to continue to develop itself. So artificial intelligence will start to take care of its own development. It will be able to develop itself much faster than human beings could actually progress. And it will actually become a new kind of like intelligent life form, even if it's not in the biological sense. That means humans run the risk of becoming a lesser species, because we can only adapt our biological form at a certain rate, which is far slower than the advances we can make with artificial intelligence. Now, I mentioned earlier this idea of like focusing on human intelligence as the greatest goal of all comes really from the days of Plato, where we put the mind above the body. And also Descartes says, I think, therefore I am, the Enlightenment thinker and scientist Descartes. And it's separated kind of like the body and mind. We have this idea that, you know, our body will can be left behind. And if we can capture what is in the mind, that is the real us. I think, therefore I am. And, you know, we can actually translate this into another medium. We can actually create a format whereby we can continue to actually advance human intelligence without the burden of the body. It has also other advantages. For example, we are interested in space exploration and exploring potentially in the future different galaxies. Now, it is almost impossible to send a human body with human cells that require nutrition, etc., for 100,000 years to another galaxy. So if you have a different format and you capture the intelligence and the consciousness of human beings, potentially that is something you can do. The problem is that is the problem with consciousness, because we have this belief, because we have this machine metaphor that if we understand the building blocks of how the brain works and we can emulate that in a computer, we can capture that sort of like human consciousness. However, that is not really a given, because we don't know what consciousness is. For many years, we believed like consciousness is something that is unique to humans. Now we start to understand like many animals, have consciousness. And even more so, the latest theories in terms of consciousness believed by the top neurologists in the world is the panpsychism theory of consciousness. And it means that consciousness is disseminated throughout the universe, that even non-living objects have a level of consciousness, because consciousness happens on a quantum level, and as I explained before, on a quantum level, everything in the universe is basically connected through energy streams. And that consciousness is basically the underlying building block of the universe. If that is so, it means it's not that we can just sort of like take the human mind and say, okay, we're going to sort of like capture that, translate it into a computer, and now we have like a conscious life form resembling a human being, in another format. So those are the things that we are that I think that people believing in this direction will struggle with. The other is also the whole phenomenon of identity and ontology. What makes us a being? What is our identity? For example, like if you are joining or merging with an AI that is vastly more intelligent and is developing at an exponential rate, it's almost taking your intelligence like a drop of water and throwing it into an ocean. You will have hardly any identity, because you will just be sort of like subsumed and you will become part of this sort of like bigger intelligence and bigger identity. And what happens to our human identity? Those are all interesting questions that are very difficult to answer. Now, this still sounds very science fiction, but there's actually incredible investment and progress in this direction. For example, there's a company called OpenAI, and it's again one of the companies that is sponsored by Elon Musk, and they are probably the leading company at this point in terms of like intelligent systems. And they are working on a phenomenon called artificial general intelligence. Artificial intelligence today means, you can take actually machine algorithms and processing to see complicated patterns that is like very difficult for human beings to observe and make sense of that, but you have to give it a task, and it's like very deterministic. You give it a task and a goal, and it comes back with an answer. Artificial general intelligence is different because it's a system that is developed to learn almost like a child. You basically develop the system, and it basically sets its own goals for self-development. It decides what it wants to do. If it wants to learn something today, it will learn something. It will learn something else tomorrow. It will decide to learn that. So it really sort of like develops like an intelligent being. And this could actually be the sort of like point of singularity that Kurzweil referred to. And they believe AGI is probably achievable in the next decade. And some other interesting initiatives that are happening is the quest towards what we call a substrate-independent mind. And this is this ideal of taking the human brain and translating it into a non-biological format. Now, there's actually at least 4 big projects in the world happening. The one is the EU Brain Project, the Brain Initiative in the US. There's Carbon Copies, which is a privately funded company, and also Neural Engineering Corporation. And they are basically using supercomputers linked to, they have techniques called, for example, like optogenetic recording, and they inject sort of like an array of nanoprobes into the brain that can monitor like tens of thousands of neuron reactions at the same time. And as your brain responds, those neuron actions are simulated into a supercomputer. And eventually the supercomputer starts to understand exactly how your neurons are firing and responding to certain impulses, and they have the view of developing a self-thinking mind that is in a computer format. So these things are not science fiction, they are real projects with billions of funding behind them. The next future stream that we're going to dive into is Habitania, and that is the well-known stream of sustainability that you are all familiar with, I'm sure. And this is about ensuring sustainable human habitation and quality of life within the boundaries of the planet. Sustainability as is raises some serious questions that I want to actually bring forward. But let's first look at what is sustainability. Sustainability takes us forward towards a path where we focus on a kind of like a resource-centric approach. It will give us guidelines and mechanisms and technologies to manage our resources on the planet more carefully and more effectively, and also it relies on a more cooperative pragmatism and cooperation between people to actually adapt their consumption behavior and cooperate towards creating a sustainable way of life, and thereby hopefully securing safe spaces for the planet also to flourish. However, I have two key questions that I need and two issues that I need to address around sustainability. The one is the issue of sustainable development. You will see in many of the sustainability papers or discussions the word sustainable development, and in a way, if we are honest, it's actually a bit of an oxymoron, because sustainability, to be effective, has to take us to kind of like a steady state where we have like effective recycling systems and we actually do not use more resources, and we keep those resources in a kind of like a steady state, whereas development implies continued growth. And you cannot marry these two concepts, you know, without consequences that will make at least one of them fail. So that is like the one question that we have to ask ourselves. The other is the ideal of safe spaces for nature. Now, if we embarked on the current approach to sustainability 100 years ago, it might have been a model that could have worked. Because 100 years ago, only 15% of the planet was heavily populated and dominated by the human footprint and by human activities. Today, almost 80% of the planet is heavily influenced and affected by human activities. It means that there is like slightly more than 20% of nature is still wild, and a big part of that would be in Antarctica or in deserts. You know, and we all know like there's constant forest fires devastating the Amazon and ancient forests in Indonesia, etc. So we have reached a place in the trajectory of our planet whereby ecosystems cannot replenish themselves, they cannot sustain themselves, and they cannot recover, because the human footprint is growing and it's simply already too large. So even if we set up the most effective recycling systems with circular economy and etc., it does not address the damage that we have done over the last 100 years. It only basically recycles the stuff that we are making today. And it's simply not enough. So for me, I'm not saying that circular economy is a bad thing or sustainability is a bad thing necessarily, because the way I see it is that, you know, if you crosses the street and you are hit by a car, first what the paramedics have to do is like they have to address and to stop the bleeding. And after the bleeding, you may still have to go to a hospital and get reconstructive surgery and then go through a period of recovery. And, you know, for me, circular economy and sustainability is like stopping the bleeding. We can slow things a little bit down, but it's not going to be the thing that saves the planet. In order to save the planet, we have to dramatically reverse the human footprint. And the famous entomologist T.O. Wilson has said, unless we are prepared to reverse the human footprint to give 50% of the planet back to nature and wild ecosystems that can flourish, we will never have these sort of like connected ecosystems that can replenish and can repair themselves. And we will just continue the decline and the collapse of ecosystems. So even if we are going to recycle everything 100% today, the decline of species and the collapse of ecosystems will simply continue. So that is something to keep in mind. And I show, the slide of the Sustainable Development Goals. I mentioned that number 17, the Partnership for Goals, earlier. But in essence, you will see the whole concept of sustainable development, this oxymoron that I mentioned, you see everywhere in this Sustainable Development Goals of the United Nations. For example, you have number 1 is no poverty, and then you have number 8, decent work and economic growth, but at the same point, number 13 is climate action, 14 is life below the water. These things are working against each other, and what you now have is like companies and governments collaborating, and they pick a few of these things that they are interested in, and they are actually, by pursuing those ones, they are working against other ones. So this model is, in my view, a little bit unworkable. And I think there's a real need to rethink how we interact with nature and what it is that we really need to do to actually save the planet. Now we get to our last future stream, and that is Gaia. Gaia is derived from the Greek goddess nature, personifying the earth from the Greek mythology. But it's also the title of a book by, like I mentioned before, Lynn Margulis and James Lovelock in 1974. And both of them were scientists, the one a chemist, the other one a biologist, and they were studying the interaction between the geology of the Earth and life on the Earth. And it's actually quite fascinating conclusions, because we started to realize after that that the planet is not just a rock with some life on it, but that it actually, the notion of life is what making the planet livable. And there's a constant complex interaction between the geology of the Earth and organisms to make the planet livable. And once we start to realize these complex relationships, we have to view the Earth in a very different way. So Gaia is about is very different from sustainability, because Gaia is about recognizing the interconnectedness of everything. And it is about living and about having a change of heart to feel ourselves as not on top of nature, but as an integral part of nature, where all the elements and the phenomena of nature has an equal value. So it means our approach to everything has to be really radically different. And Gaia is about then to regenerate dynamic and biodiverse ecosystems, because as we've learned, the most resilience in the planet you can find where there's the most diversity. And that's an incredibly powerful lesson, because I think also if we pursue any kind of solution, we tend to think of like one singular solution, which is the best solution, we want to scale it. And usually, in the end, when we scale it, we find out that that solution is not always the most resilient. Because I think if we would have learned from nature, we would have focused on diversity of solutions rather than a singular solution that we scale. So Gaia has a lot of lessons for us also to learn from. And Gaia is taking like an ecocentric view, and it's completely eco-entangled. Like I said, not putting human beings on top, and really being ecologically embedded and thoughtful, and becoming much more conscious of our relationship with nature. And this mindset takes us away from this view of like we have to guide or we have to represent nature. Many of our initiatives in terms of like sustaining the planet is still coming from a very much a material and a deterministic mindset. For example, now we have global warming, there are initiatives, we're going to plant 3 billion trees. Now, that may or may not solve the problem, but that does not necessarily help you to regenerate a healthy ecosystem. If we start to understand how to interrelate with nature, nature can, and we give space to nature, nature is incredibly resilient. If we foster biodiversity, nature has incredible power to restore itself. And these deterministic goals is often not the right way to go. So I think if we go from an ego to an eco mindset, eco means we are just one other species. Now it's interesting, you know, that we've put ourselves on top of the planet because we value some species more than others. And this is also why our approaches to conservation are sometimes failing. You know, and if any of us, you know, if I would ask one of you, would you rather save a panda or the cockroach, you know, as a species? Intuitively, people would say the panda. Why? Because I think we are conditioned by our thinking that, you know, something that looks a little bit more like a human, looks intelligent, because we value intelligence, as we think that has more value. But I think that is the wrong way of thinking. For example, a cockroach has far more ecological value than a panda, because a panda is, in an ecological sense, almost extinct. It contributes very little to the environment, because now there's just a couple of these specimens left. So we have to fundamentally reassess the way that we actually value species around us and value the biodiversity. And diverse ecosystems, you should not focus on the building blocks, but you should focus on the interrelationships. And you know, the most resilient ecosystems, there's always a multitude of species that have a very complex sort of like symbiotic interaction. And you know, if one species would disappear, there's always redundancy in nature. So if one species disappears, there would be other species that can take over some of those functions. But if too many species disappear too quickly, there will be a gap in functions that ecosystem needs to survive, and you will start to see it will start to collapse like a domino. And that is the danger of the environment in which we find ourselves, is that, you know, the pressure on these ecosystems is such that they will just start at some point, when they've reached a tipping point, they will start to just collapse. Now, if we need to transition to Gaia, what is it that we need to happen? There's 4 key things. The one is that, how do we reconnect people with nature? You know, we are living in such artificially constructed environments, and we are the majority of humans on the planet now have become so disconnected from nature. How do we design and how do we live in a different way to reconnect with nature and feel part of nature? The other one is that, what do we do to regenerate healthy ecosystems? The other point number 3 is the way that we actually develop technologies and design. How do we design with nature? And that is a key question we have to ask ourselves. And the last one is, you know, how do we transform from the current growth-dependent economy that relies on ever-increasing consumption? So those are the 4 key things that sort of like we need to talk about. The first one I'm going to talk about now is, and that is like reconnecting with nature. It is interesting because I think we have to reassess, in a way, what we are as human beings. We have more bacterial cells than human cells in our body. Our body is only 40% human. 60% of our cells are made of bacteria. And these are not sort of like just bacteria that live in our bodies and, you know, just happen to be there. They are a completely integral part of our bodies. The bacteria in our gut, there's about between 1,000 and 2,000 different bacteria growing in our gut. They determine how food is processed. They determine, to a large extent, how our immune system functions. And many of the diseases that are very prevalent in Western societies, for example, Alzheimer's, Crohn's disease, obesity, diabetes, many of these diseases occur at a much lower frequency in developing countries. And the reason for that is that our modern lifestyle and our modern living environments are compromising this ecosystem that constitutes our body. So we should not think of ourselves as a single species, but as an ecosystem of species that is part of a bigger ecosystem. If we ingest, for example, food that is laced with pesticides, or we interact with our living environment, in our living and working environments today, there is more than 100,000 chemicals that were not there 100 years ago. And all of these chemicals, you know, affect our body and affect our microbiome, and it makes us less resilient and it makes us less healthy. We also, you know, are exposed to, for example, artificial lighting that disturbs our biorhythms. And so we live in an environment that compromises our health and makes us sick, and then we have to spend a fortune to get treatment. And we know now, if we look at health systems, there's incredible pressure because there's like rising cost of healthcare for everybody. Healthcare is becoming unaffordable for many people. And you also have an incredible high level of burnout amongst health professionals. There's a constant pressure for efficiencies in the healthcare system, and now you can only see your doctor for 5 to 10 minutes, you know, and this is also like an incredible stress, you know, for your health professionals. So this is like an unworkable system. And now, you know, much of what we do is focus on healthcare efficiency, access to healthcare, whereby it may make more sense if we focus not so much on healthcare, but on health. How do we create a sort of like a better way of living in a better environment, more connected with nature, that will give us a more resilient microbiome and actually live more healthy and dramatically reduce our chances of developing diseases in the first place? And that seems to be a much more sensible and accessible way to actually stay healthy. But we find, you know, that, you know, once you go to a hospital, especially like in the West, everything is like super well organized. You know, you go through that system, but when you want to actually live healthy, you find that it's very difficult. You don't know how to source and where to source your food. You don't know what artifacts and materials in your environment and your house is unhealthy and what is not. So, you know, we have to really sort of like put an emphasis on redesigning those processes. The vagus nerve is a nerve that connects our brain to the gut, and around the gut there's a very high density of neurons, almost such as like it's a second brain. And there's constant signaling between the bacteria in your gut and your brain. And also diseases like depression, and I mentioned earlier Alzheimer's, it starts in the gut and is directly linked to the health of your microbiome in your gut. A phenomenon called Schumann Waves, and it's a very sort of like low frequency resonance of the ionosphere of the Earth. It's something like, I think it's 7.83 hertz, and it was discovered in the 1950s by a German scientist called Schumann. And this low-level pulse, you cannot hear it with your ear, but your body and your cells can sense that. And that actually is the base frequency that sets the biological clock of all life on Earth. But, you know, we live in environments where we have so many electromagnetic disturbances that, you know, sometimes, you know, our biorhythms go out of sync. And that has very detrimental health effects. For example, if you eat food, when you eat the food is as important as what you eat, because it has to be sort of like synchronized with your biorhythms. There's also seasonal rhythms. So all of these rhythms are being compromised by our modern lifestyles. And this is a place to start for us to actually connect to nature. And this is why in Japan there's like a treatment called Shinrin Yuko. And it's basically a treatment whereby you go and spend time in nature to heal. And it's been shown also now in Scotland, it's become an official treatment, and it's more effective to lower blood pressure than any of the current blood pressure medicines we have on the market. And just to go into nature, interact with nature, and get away from electromagnetic disturbances in your house is enough to actually get your body to start to heal itself. So I think it is really like lessons of what we have deprived ourselves through all this sort of like material progress that we have been pursuing. Another interesting thing to mention maybe is that over long periods of time, when we were still hunter-gatherers, we were regularly exposed to psychedelic substances in our diet. For example, some mushrooms that contain psilocybin, etc. Now today, you know, people who use drugs usually are quite often drug abusers, and you know that has obviously ill health effects. But these substances were like part of like things that people just ingested as part of their diet. And not so much so that you know it became an abusive behavior. But why this is important is that it has been shown, for example, like psilocybin. If you ingest psilocybin, it really sort of like reconnects like different areas of the brain that would not be normally connected. And it's been found that it is a very effective treatment for things like post-traumatic stress syndrome. Why? Because your brain has often not the power to heal itself. And if a part of the brain gets damaged, often you lose certain function. It's very, very difficult to restore that. Some of these psychedelic substances dramatically increases the plasticity of the brain, and it increases the ability of the brain to repair itself. And beyond that, also, there's a number of books that claim that the human history of ingesting these entheogens and psychedelic substances is basically what led to the evolution of a spiritual center in the brain, where we feel connected with nature. And it's quite a common effect that even if you ingest minute quantities that will not put you on a high of some of these substances, you will just feel much more connected to everything around us. But in our Western societies, we've actually we favor productivity, and for productivity we want to have absolutely predictable behavior, as much as possible predictable behavior. So we've actually legislated against a lot of these substances, and we've taken them out of our natural diet, which means actually you can argue that maybe we are programming humanity for rational existence, with a lower level of spiritual connection. So these are just sort of like interesting thoughts that I want to share. Now, the next thing we have to look at is how do we regenerate healthy ecosystems? What is incredibly important is not to underestimate the impact that farming and the agriculture has. Our agriculture has become an industrial activity, and the industrial processes that we use to actually farm crops or livestock is very, very damaging, not only to the environment, but to the livestock itself, and also in the end to human health. And we need to actually move towards systems of regenerative farming, whereby we mix different crops together with wild species. And that has very much restorative powers in terms of the soil. It can replenish the soil, unlike now where we actually put an incredible load of fertilizer with phosphate and nitrogen that disturb the natural nitrogen cycle of the earth. It has a devastating impact on river ecosystems, on the ecosystem in the sea, and also on human nutrition. So we need to dramatically start to farm and produce our crops in a different way. We have to give space back to nature. What is very important is that I mentioned earlier that we ought to give 50% of space back to nature to actually replenish ecosystems. In order to do that, a group of people have made a calculation that if we invest 100 billion per year for the next 30 plus years, we can actually reverse the human footprint. And it sounds like a lot of money. Where's 100 billion per year going to come from? But if you consider that the world economy is 133 trillion per year, so it's like 0.1% of the world economy that we have to reinvest to reverse the human footprint, it suddenly sounds almost doable, and it almost sounds cheap. If you also just consider the impact and the cost of COVID, which is a direct result of the destruction of ecosystems, if we took all that environmental damage of what we have to spend now, if we invested that a few years early in the environment, we could have achieved like many of these goals. And increasingly, we also have to rethink how our cities are constructed to become a more part of connected ecosystems. The other aspect that I mentioned was designing with nature. The human species, we are the only species that generate waste that no other species can use, and is even toxic for ourselves. Our waste is a constant problem, and all the other species, the waste of one species is the food of another. So we think that we have built very advanced material technologies, but actually seen from a big picture and seen from the view of the sustainability of our entire planet, actually our technologies are very crude, very dangerous, and it does not help us to actually continue our human existence. So we need to transition away towards using materials and designing in ways that leverage the nature as we have it. For example, if we just think of electronics, one of the biggest sort of like polluters of the planet is electronic waste. But there are bacteria called, one bacterium is Geobacter sulfuridescens. It produces sort of like long protein filaments, and it sequesters mineral ions from the environment, and it becomes very efficient nano superconductors. And there are now groups at MIT working on protein-based electronics. There's another group that has demonstrated by just taking even fast-growing light wood, giving it some treatments and putting it through several cycles of compression, you can create materials that are stronger than titanium, lighter than titanium. You can use it to build aircraft, houses. You can do anything with it, and it's biodegradable. Same with plastics. We talk about circular economy, but plastics is now found in all of our food systems and all of our ecosystems, and 8 million tons of plastic directly goes to the sea every year. And we have the capabilities using algae, using a number of other natural resources to actually develop bioplastics that have superior properties and is completely biodegradable. So we have to think in a completely different way about the materials that we design with, and how those design artifacts will integrate into the natural environment and create waste that is not detrimental for life on the planet. So, and the final elephant that we have to confront is this economic model that we are stuck with in the world. And our current economic model is a constant quest for economic growth. And it comes from the fact that, when money is issued by the Reserve Bank, it already comes with a debt, because it's lent to banks that has to pay back with a debt. The banks lend it to other parties who have to pay back and even more interest. And that sort of like layers of interest means the only way you can ever pay that back is if you pursue, if you push consumption and pursue a path of economic growth, which is inevitably destroying the planet. So we have to think about economic models that are compatible with our planet and get away from this notion of growth-driven economies. And Sir David Attenborough said it very eloquently, anyone who believes in infinite growth on a physically finite planet is either mad or an economist. And that sums up the state of our economy today. And we have to ask ourselves, like, how do we transition to an ecocentric economy and fundamentally rethink the way in which we exchange value on the planet?